simplistic because you don't have one without the other. You need to have both, okay? But there's not a disconnect, and basic research does not live in a vacuum. Perhaps the Vatican does, but basic research doesn't, okay? So moving on from that, if you actually take numbers, then you can see that the big pharma is reliant on externally sourced products, and this is an analysis until 2007. And in this bar, you can see the in-licensed products in the top 100. So basically, how many of the products that are in the top 100 of their sales have actually been licensed in? And you can see that around half of them have come from external sources. Most of those sources are biotech companies. And those biotech companies actually start their life out of research institutes. So research is sort of driving innovation. If you actually look at the revenue generated from the in-licensed products, then you can also see that, in fact, half of the revenue that they create and of the top sellers is actually from in-licensed products. So it is extremely important for the pharmaceutical industry to interact with the academic world and to source in ideas because their pipeline is actually pretty dry. Okay. So from that, let's move on to this problem here. There's something called the funding gap, which some of you might have heard of. And this funding gap basically describes the problem that there is public funding in academic research institutes to take research to a certain step. So some places it's to discovery, in some institutes it's up to it's hit to lead. So when you have a target, they can actually make lead compounds. But at some point, you need to do optimization on that, and you might also need to do preclinical. And there is a problem that basic research stops too early, and that commercial or industrial interest only comes at a later stage. So there's no one to embrace the very early results out of basic research. So there are two ways to solve this. And one of the ways is to actually say, well, basic research should actually take things further. And at the same time, you also can say, well, industry should actually take a step back and actually engage earlier. And this is what is usually done in these models to actually bridge the so-called gap. So things that happen if you actually look at public funding, sorry, this is the value. The value increase actually comes at a later point. And it's only at a later point, at a point where the value of your potential product is significant enough, will you actually acquire the interest of the pharmaceutical industry. So what can you actually do? Well, you can start things like industrial collaborations, where you engage industry at an early stage. For them, it's cheap to buy into it and to help you develop things, as long as you have certain checks and balances. So going back to Tim's comment, you have to make sure that you actually control the situation, okay? And there are means to do that. There are things that you can do, such as startups, private-public partnerships, or public-funded consortiums that will take things actually further. So these are all solutions to this problem. So here's postulate, or postulates 3. Basic research is the driver of innovation, without a doubt. There is a funding gap, and that requires things like private-public partnerships. And the funding of governments and public funding agencies actually creates an obligation for basic research to make the benefits of their research available to the public. Okay? And the conversion of the research results to products is what actually brings direct benefits to society, so to all of us taxpayers, in the form, especially, we're talking about the life sciences, that's where I come from, in the form of medicaments, therapies, diagnostics, and medical devices. Now, here are some often quoted misnomers about industry and about commercialization and all the caveats and all the flaws. So one of the things that is often said is patenting prevents publishing. Now, usually, when a scientist actually writes up their paper, from that moment until it actually gets published, peer-reviewed and published, you have at least 3 months. If at the same time, if not earlier, the scientist actually hands that in as an invention record, then the 3 months is more than plenty to actually file a patent application. And a patent application does not prevent a paper from being published. And you don't need to wait until a patent is actually granted before you publish it. So really, there is no conflict. It's not a problem. Another thing you hear is patenting hinders academic research. Well, does it really? Tim actually brought up the point, which he's absolutely right about. Academics probably hinder academic research a lot more than patenting hinders academic research because, as I mentioned before, it's become a career, so people are competitive. So academics are people, and they're no different to the rest of society. So they sometimes don't want to share their results with their competitors because they want to be the first to publish. Okay? Any patent, and every patent that is ever filed, there's something called the academic research exemption. So, or research exemption, better to say. So if you're using patents, things which are claimed in patents for research purposes and not for commercial purposes, you're free to do so. So patenting is not really a problem. Whether the flow of information is a problem, that can be controlled. So usually, in our license contracts, we always say that if anything gets developed, we want to have the rights to actually use it for academic research. Okay, we want the those rights granted back. So that's not really a problem at all. Third misnomer, industrial collaborations hinder free dissemination. Well, not really. Again, you can regulate that. And in fact, the industry is interested in free dissemination of the results because, just like for scientists, when you have publications, that is actually used as a marketing tool because you raise interest. So it's not really a problem. And last but not least, it's often said that industrial collaborations impact negatively on basic research. Well, let's have a look at the next slide. Does it? You would assume that if that was the case, then all of those institutes, and this is the ranking between 1999 and 2000 in molecular biology and genetics, favorably, EMBL actually happens to be in position number 4 and is a top-ranked European institute. You would think that, and all of these institutes are extremely strong in technology transfer and in commercialization. So if ties with industry impact so negatively on basic research, you would assume that those research institutes that are the strongest at translation of research should actually be really bad in basic research. But they aren't. They're all in the top. Okay? So I hope to have convinced you that perhaps not everything is as bad as it seems like. Now, what I would like to do now is just take a couple of moments to tell you about where I come from, what we actually do. So, as I mentioned, EMBL takes ideas to discovery. We're then responsible as Emblem Enterprise Management Technology Transfer. When we like each other, we say Emblem. We take things from the discovery to the product phase, or the protection phase, and then we actually commercialize it either by licensing it out to establish companies, and that is probably 95% of the things that we do is to license it out to establish companies. Exclusively, co-exclusively, non-exclusively, whatever is required to make sure that those products become widely available to the broad public as soon as possible. That is the aim of the game. That we want to make some money while we do it is fine, but making money is not the main aim. Okay? And we can also put it into startups, but that's a small, very small fraction of what we do, and we have an associated venture capital fund that actually helps us fund those companies. So the mission of why EMBL engages in technology transfer is this return, fair return. So money is a small part of it. It's also, and more importantly, to spread the benefits of the results coming out of basic research to all of the Emblem member states and to society at large. And last but not least, to improve human health. I mean, that's why most of the people who actually engage in the biological sciences in the beginning start their career because they want to cure disease, because they want to help mankind, and somewhere it gets lost along the way. So this is what we have done, and I see that I have about 3 minutes left. Over the last 10 years,